Professor Bumbleweed here, nuclear fusion. The star trick where light atoms merge and release absurd energy. In a few minutes, this silent tour shows how it works, why it matters, and why it stays stubbornly difficult. Bring curiosity, leave myths at the door. This mini deep dive stays equal parts fun and correct. Crisp visuals, honest physics, and sarcasm kept on a leash. Fusion powers stars, yet it still refuses to behave in a lab. Time to move past the trailer and look closer. Nuclear fusion means two light atoms slam together so hard that they stick and become a heavier atom. A tiny bit of mass turns into energy, so heat and light burst out. Yes, it sounds like magic. It is just physics being dramatic. People mix them up, so here it is. Fission breaks big atoms. Fusion builds bigger atoms from smaller ones. Stars run fusion constantly, turning hydrogen into helium and releasing energy that travels outward as light and heat. Recreating that on Earth is the hard part. Fusion is picky because nuclei carry positive charge and push each other away. To get them close enough to stick, the fuel reaches insane temperatures and becomes plasma, where electrons and nuclei move freely. Heat makes collisions faster, but it still feels like herding angry bees. Even if fusion sparks, it counts only when the plasma stays hot and packed long enough to keep reacting. Magnetic confinement uses powerful magnets to corral plasma in a ring. Inertial confinement squeezes a tiny pellet so violently that it fuses before it blows apart. Both sound easy, neither is. In a tokamak, magnetic fields act like invisible tracks for charged particles. The plasma spirals around inside a vacuum vessel, staying mostly off the metal. Mostly is the annoying word. The edge still hits components, dumps heat, and threatens stability. Fusion engineering is the art of controlling that chaos long enough to get useful reactions. Inertial confinement takes a different approach. Compress the fuel so fast and so evenly that it fuses before it has time to fly apart. A tiny pellet gets blasted from many directions to create extreme pressure and temperature at the center. The timing needs to be absurdly precise because physics is picky like that. Fusion fuel sounds simple until you count the details. Deuterium comes from water, so it is not exactly rare. Tritium is scarce. So many reactor concepts make it on-site by letting fusion neutrons interact with lithium in a surrounding blanket. So, yes, the reactor also functions as a fuel factory. Convenient, complicated, both. In many deuterium and tritium reactions, the helium stays in the plasma, but fast neutrons escape and slam into the surrounding blanket. That impact heats the blanket, and coolant carries the heat to make steam and spin a turbine generator. The catch: those neutrons also damage materials, so parts need shielding and replacement plans. Fusion is hard for boring reasons: controlling a restless plasma, handling massive heat loads, and keeping materials alive under neutron bombardment. Add a fuel cycle that includes tritium, plus magnets and power systems that hate mistakes. The physics works, the engineering demands perfection. Reality stays unimpressed by hype. Progress in fusion looks like more stable plasmas, better confinement, and experiments that produce significant fusion energy. Some facilities demonstrate ignition in short bursts, proving the reaction can run strongly under the right conditions. Turning that into reliable electricity needs repeatability, durable materials, and efficient heat extraction. So yes, it is moving forward, just not at movie speed. Fusion means small atoms combine. A bit of mass converts into energy, and the fuel becomes a super-hot plasma. You see two main confinement ideas and the real-world headache. Neutrons dumping energy into a blanket while also damaging materials. The fixed reactor cross-section on the television is the whole story in one frame. If this fusion explanation earns a tiny spark of interest, press like so I track what people enjoy. If you want another topic, drop it in the comments and give the animators something to chew on. Without your ideas, I stay silently enthusiastic forever. See you next time.